So like we learn this kind of a concept. Okay, so how we can like manage the data first. Okay, so how we are able to manage the data, how we are able to manipulate the data and bring it in a proper format. Okay, so to bring the data into a proper format is the like that is a fundamental step. Okay, so that is the more important step, because if you are not able to understand your data, okay, so you are not able to perform you are not able to proceed further. Okay, so the most important thing is you first need to understand the data. You first need to manage the data. You need to bring your data into the format by using a pandas or maybe a simple Python functions. I think you saw that thing in yesterday's session, so that we are able to perform some kind of a task. We are able to perform some kind of we are able to make some kind of a plots or graphs to get the intuition, to get okay, so this is what going on inside my data set. Okay, so fine, these are all the things which we learned in yesterday's session. Now so in today's session, I think yesterday's session is more about statistical modeling. Okay, so at last we are able to build a statistical model. Now in today's session, I am going to give you a practical implementation of a predictive model. Okay, so by using your model, how you are able to predict maybe some future cases. Okay, so to build any kind of a predictive model, to build any kind of a machine learning model, you need to follow this steps. Okay, or you need to go through these stages. Okay, so the very first stage is problem definition and hypothesis generation. Okay, so this is the very first stage which we need to think. Okay, so we need to identify the problem first. Okay, so I think many of you guys yesterday gave me some kind of a problem. Okay, so can I solve this, or can I solve this by using AI ML? So I can give you okay, so I am able to provide some kind of a maybe a scenario or something, only if I'm able to understand the problem. If I'm not able to understand your problem, that what exactly you want to identify, or what exactly what are the exact problem you are facing, I'm not able to give you any kind of instruction or and all. Okay, so the very first thing, you need to identify the problem. Then we need to collect the data. So data in one sense, you can say for any machine learning engineer, or to build any kind of a machine learning model, data you can call a data as a oxygen. Okay, so data is kind of an oxygen for every data scientist and a machine learning engineer. Okay, so without this data, we are not able to proceed, we are not able to walk a single step. Okay, so that is so we need to understand that how we are able to collect the data, and what are all the sources from where we can collect the data. Then exploratory data analysis. So after collecting the data, we need to explore our data set. So I think this thing we already implemented in yesterday's session. Now the fourth stage is feature engineering and pre-processing. So you need to bring your data into a more informative way. Okay, so maybe by removing some noise. Okay, so I think we talked about this thing in yesterday's session also. So by removing some noise and by adding some maybe extra or informative feature, we can make our data set much more informative. Okay, so that is what we are trying to achieve in this stage, with the help of pre-processing and feature engineering. Okay, so at last we try to build a kind of a data set. We are trying to represent our data set in such a way that we are able to perform we are able to build a model. Okay, so this is a very important stage for any for any machine learning engineer or for any data scientist. Then the fifth stage is selecting the best algorithm. Okay, so based on so what kind of a problem you are having, so based on that problem, you need to select the best algorithm for your model. Okay, so although today in just one session, it's not possible that I'm going to give you the glimpse of each and every algorithm, but yeah, but as like if you continue this journey after this workshop, so you are able to see that in like in case of a supervised itself, there are maybe around 12 to 15 algorithms are available. So now you need to grab some kind of a knowledge, so that you are able to select maybe a 3 or 4 like algorithm out of that 15 algorithms. Okay, so definitely you need to make a comparison, but you try to make a comparison only in between 2 to 3. Okay, it's not like that you are going to check with each and every algorithm, each of 15 algorithms. Okay, so that is not feasible, and that is not that's not like a good way to create any kind of a model. Okay, and the last stage is after selecting the best algorithm, just use that algorithm to build a model, and then go for the evaluation. Okay, so evaluation means you need to yeah, I think that I didn't explain this feature engineering part yet. Okay, so just wait for this slide when I reach to this step. Okay, and then you are able to understand the difference. So we need to build a model, and after building a model you need to evaluate your model. Okay, so evaluate means you need to check the performance. Okay, so how my model is performing, whether it is good enough or not, or whether I am able to achieve a better result or not. Okay, so if my model is good, if I'm able to achieve the better result, so yeah, I can go for I can go for the deployment. I can deploy the model, and I can ask the industry or the company to use this model in for the real world scenario. Okay, so because my model performance is good. Okay, now let's go step by step. Let's try to discuss each step in a detail, and then and maybe I think in some of the step I need to use my pen and explain you some things. Okay, so I think first stage is very clear to all of you. I don't think that we need you need a lot of explanation for this first stage, because the first stage is very easy. It's just a fundamental and the basic thing, that before starting before start implementation, or before build a model, you need to understand the problem. Okay, so you need to understand, okay, whether this problem really exists or not. Okay, so if the problem is not that much dangerous, or maybe it is not by making a model you are not able to help any person or maybe a society, so yeah, you are not going to in depth of something. Okay, so you are going in depth of something only, you know that okay, so this model is going to give you a kind of an intuition, or kind of a thing, so that you are able to you are able to achieve some kind of a goal. You are able to achieve some very you are able to achieve something. Okay, so you need to understand the problem statement first. Okay, so I think if someone asks you to build a model to which are able to detect the diabetic patient, or which are able to detect the maybe a cancer, or maybe a COVID. So these are the yeah, you are able to understand. Okay, so I need to build a model, because and this model is going to help the society. With the help of this model, I'm able to help the people, I'm able to help the society. And with this maybe they are able to detect the COVID at very early stage, and then they can go for the treatment. Or maybe they are able to detect the cancer at very early stage, and then go for the treatment. Okay, so these are all the things which you need to realize, you need to think. Okay, so whether this problem is appropriate, whether my model is able to solve this problem. Okay, so you need to understand this this basic things. Okay, so these are the conceptual thing. So you need to understand this thing first. Okay, and then only you can proceed. Okay, I think in yesterday's session someone asked me maybe some kind of a task processing, and I said, okay, so I'm not able to understand the exact problem which you are facing by just a single statement. Okay, so and I'm not able to give a proper answer. So yeah, if you're not able to understand the problem exactly, okay, so what the exact problem you are facing, we are not able to answer, we are not able to we are not able to build a model. Okay, so to build a model, we need to understand the problem first. Okay, so this is a very important step. Now, along with that, you make some kind of a hypothesis. So a hypothesis means a assumption. Okay, so uh, everywhere, okay, so maybe if you are just a shopkeeper, or maybe if you are just by performing any, but before performing any kind of a task, you always try to make some kind of an assumption. Okay, so maybe you generate some kind of an hypothesis, you may generate some kind of an assumption. Okay, so this is my assumption, this is what I am thinking. So this is what you are trying to assume. Okay, so maybe this may possible, this may not possible. So based on your assumption, you think, okay, so maybe this factor is really important for this model. Okay, maybe if I take an example, so suppose someone asks you to build a diabetic prediction problem, maybe to make a model which can predict the diabetes. Okay, now based on your knowledge, okay, so you don't have right now you don't have a data, and right now you don't have maybe you don't apply anything, you didn't apply any EDA or maybe anything, but based on your own knowledge, okay, so based on your own experience, maybe you experienced with some maybe a diabetic patient. So based on your own knowledge, you can think, okay, so maybe a sugar level is very important factor to predict like a diabetes. Okay, so maybe if because so this is just based on my knowledge, so maybe I can say, okay, so if the sugar level is very high, so if any person sugar level is very high, so there must be a case of diabetes. Okay, so you can make this kind of an assumption. So guys, please mute yourself if there is a noise. Okay, so if there maybe, okay, so always you always make some assumption, you always make some hypothesis, you always build a kind of an idea in your mind before start processing. Okay, so like in case of a diabetes, so in any other case also, based on your knowledge, you make some kind of an hypothesis, and that hypothesis, definitely possible that the hypothesis may be wrong, or the hypothesis may be true or false, but that hypothesis will actually help you to process. Okay, so this is the the first stage, this is the first fundamental stage which you need to follow. You need to understand the problem, and then if you are able to understand the problem, you can build your hypothesis. Okay, now the second important stage, the second important thing is data collection. Okay, so as I told you that data is kind of an oxygen for building a machine learning model. So now you need to understand that by which mean you can you can collect a data. Okay, so what are all the sources, or what are all the maybe techniques through which you can collect a data, you can gather the information. Okay, so the very first way of collecting the data is by conducting a survey. Okay, so the survey can be an offline survey, it can be an online survey. Okay, so I think at least in India, before any election, before any election result, every TV channels and every news channel and every maybe survey companies, they make some kind of a survey. Maybe they go people to people and ask some people's persons, and then and so they conduct a kind of a survey, and then they give you a kind of an exit polls. Okay, so that exit polls maybe sometime wrong or maybe sometimes correct, but they give you an exit poll. Okay, so this party is going to win tomorrow. So that is that kind of a survey you can so whenever you try to make some kind of a model based on a real world data, okay, and you try to solve maybe some real world scenario or real world problem, so you always need to you need to conduct this kind of a survey. Okay, so nowadays lot of researchers, okay, so suppose if you're also in research and you are doing not only for PhD. Okay, so you don't want to do maybe a PhD, but you want to you want to make you want to do some kind of a research in some area. just to enhance your knowledge. Okay, maybe out of the curiosity, or maybe just to enhance your knowledge, you want to perform some kind of a, you want to do some kind of a research. Okay, so if you genuinely want to research that thing, so you need to conduct a survey. So what you can do, you can create a Google form. And what are the informations? Okay, so what are the information you want? You just mention that information, you just mention that thing in a Google form, and then you can spread that Google form into like a group, maybe in your school group, college group, maybe in your working group. And you can ask the people, okay, so please fill this form so that I can start with my research work. Okay, so this is also a possibility. So I am connecting with I am in a lot of maybe a machine learning or data science group, even like in Slack with a lot of researchers. So they're doing this kind of a stuff. Okay, so they send me a Google form. Even they send a Google form into a group, and they ask people, okay, so please fill this Google form so that I can continue my research. Okay, so if anywhere you want to if you want to make some a model for the real world scenario. Okay, so you want to solve some real world cases, so you need to conduct this kind of a survey. Okay, so definitely nowadays like offline survey is not possible. So yeah, you can conduct an online survey. Okay, then the second way of collecting the data is is from a website. Okay, so maybe the model which you want to build, okay, so or the problem which you have that demands maybe you that if you want to make sentiment analysis for you want to make a fake news detection system. Okay, actually we work on this project maybe 1.5 year before. So I know that so at that time what my team does is we collect data, we scrap the data from a lot of news websites. So we only want to we only want a news data from the website where we have a technical news. Okay, so the news related to AI, or maybe a blockchain, or maybe the technical news only. So we just select those kind of a news channel. It may be maybe from the Indian origin, it may be from any other country. So we select a technical news channels, and then we scrap the data which is relevant for our model. Okay, so because every each and every a website is having lot of data. Okay, so there is a lot of information going around. So maybe you can see a video, or maybe there is some audio. So there are a lot of things going around. Okay, so you don't need each and everything from that website. You only want some relevant text, or maybe some relevant tags to make a model for a future. Whether okay, so suppose if any new a news comes into the picture, so you are able to recognize whether this news is fake or whether this news is true. Okay, so this kind of a model we build maybe 1.5 year back. So we collect the data in this way. Okay, so we try to scrap a website, and we scrap only the relevant data from that website, and then we go for the modeling. Okay, no, yeah, web scraping is possible, but one thing which is implemented nowadays, that in each website, so people nowadays feel more insecure, so they put some kind of a restriction in their website. Now if you know that this is the only website from where I can get the relevant data, and you see that there is a restriction. So what you can do is you can ask the owner to give you the permission, and maybe he can charge something, and he can give you the permission, and you can scrap the data. Okay, so that is also a way of collecting the data from maybe any particular website. uh yeah for web scraping you can use yeah, beautiful soup, or scrappy. So there are a lot of tools are available. So scrappy is available, selenium is there, beautiful soup is there. So you can try to explore these terms. Okay, so if you uh, I can write a name. Okay, so you can search for beautiful soup. Okay, you can search for selenium, you can search for scrappy. Okay, so You can search for this three things to scrap website. Okay. Now the third technique through which you can collect the data is online learning platforms. Okay. Now maybe conducting a survey, maybe a costly one or maybe a time consuming, and then if you ask to that owner, then also it may be it charge something. But if you now but if this open source platform or this learning platform, if you try to collect the data from this open source platform, so it is like easy and free, and it's not a time consuming at all. Okay. So but the only problem is that the data which is available on this platform, so 70% of the data is not from the real world scenario. Okay. Only 30% of data is from the real world scenario, and 70% of the data is like just created by some experts. Okay. So that those 70% of data is created uh, the people like you and like me who want to develop a skill in in the field of data science. Okay. So so there are like a different variety of data. So suppose if you are a beginner, okay, so in these 2 days I'm so this 2 days workshop is genuinely for the beginners. So so if you're a beginner, if you just started a machine learning, or if you just started with the data science, so you can take a small data. Okay. So you can take a less complex data from this website, from Kaggle or UCI. Although papers with code is so papers with code is only having a like complex data. So as a beginner, I only recommend you to go for a Kaggle or UCI. So you can use Kaggle to collect maybe less complex data. Suppose if you are a beginner, so and after that, suppose if you are at an intermediate level, so you can take some complex data. And maybe if you are you can think of yourself as an expert, so you can directly collect the data from papers with code, or from Kaggle competitions. Okay. So competitions data are actually complex data, and most of the time, 90% of the time, the competitions data are from the real world. Okay. So so if you feel that yes, now I'm an expert, so you can go for the competitions data from a Kaggle, UCI, Analytics Vidya, papers with code. So if you if you try to check your expertise, so you can go for the competitions data. And but yeah, fine, that is that takes some time maybe. But this is just for a knowledge that these are the websites available through which you can collect the data. And I can add maybe one more website, that is Analytics Vidya, so AB. Okay, fine, I will add that also. And the last and the most dumb kind of a process to collect the data is you can create your own data set based on the knowledge. Okay. So based on your knowledge, or maybe based on some experts knowledge, you can create your own data set. So maybe if you're not able to collect information by a survey or maybe scrapping, and so you can go for this last thing. Okay. Because you don't have any options left. Okay. Now come on to the feature engineering and data pre-processing part. Okay. So feature engineering is is the most important part, I can say, for any machine learning model. Okay. So not from a single survey, it is you can, if you write this thing, so you are able to observe, you are able to see this kind of a statement everywhere, that most of the data scientists, okay, so most of the data scientist or maybe ML researcher or a programmer, they spend 80% of their time on this step. Okay. So all you can say till this step, because if you don't have a proper data, okay, so if you don't have a data, or you can say a proper data without noise, or maybe without much information, so definitely no matter what kind of a model you are using, okay, so it may be a complex model you are going to use, but it will not give you a accurate result. It will not give you a kind of a performance which you want. Okay, so this step is very important. This pre-processing is very important. You need to like bring your data in a form so that it's become easy for your model to it is become easy for an algorithm to build a model. Okay, so yeah, so anyone can okay, so anyone, I think no one of you is trying to eat like maybe uh, uh, like different kind of a variety of foods together. Okay, so everyone wants to see like everyone wants to eat like a food in a proper manner. Okay, so in your plate you want everything uh, everything in a proper manner. Okay, so you want like a chapati at one place, then like maybe a rice at one place, then maybe vegetable at one place. So you want each and everything in a proper manner. Okay, so you don't mix each and everything and just start eating. Okay, so that is not a way. Okay, although everything is going on to your stomach, but you're not trying to eat in such a way. Okay, so that is what we are trying to do in this step. And if you're able to see this picture, and if you're able to if you're trying to understand this picture, okay, so this is what it is trying to like tell you. And always remember that better data is better data can beat fancier algorithm. Okay, so no matter how fancy your algorithm is, how complex your algorithm is, if your data is not good, if your data is not better, so you are not able to generate a better result. Okay, so and this is what he's trying to tell. Okay, so he's trying to pour the data and then collect the answer from the other side. And he's asking that what if the answer is wrong. So yeah, the simple answer is just steer the pile until they are looking they start looking right. Okay, now it's time to discuss those techniques. Okay, so the techniques through which we are able to pre-process, or we are able to make our data set ready for the modeling. Okay, so the very first step is removing irrelevant features. Okay, so irrelevant features means, again, this is a kind of a noise which we are having in our data set. Okay, so irrelevant, so there are like maybe so irrelevant feature means the features which is not important at all. Okay, so the feature which is not important at all, it is only going to just trying to make some kind of a space unnecessarily. Okay, so like there are a lot of features which is not informative at all, which is not going to give any kind of information, and the feature is not helpful to build a model. Okay, but then also the feature is available over there. Okay, so you need to remove those irrelevant features. Okay, so I think if I take an example from yesterday's session, so you are able to see that there is one feature such as order ID. Okay, so order ID is like not helpful to build a model. And suppose if you want to build the model and we want to see what may be the future cell. Okay, so order ID is not helpful there. Okay, so order ID is not giving to you give you any kind of insight or any kind of information. Even the name is not helpful, your name is not going to give you any kind of insight. So you try to remove this kind of a irrelevant feature, this kind of a irrelevancy you need to drop from your data. Okay, so any tool for data pre-processing which handles all points mentioned, uh any tools, no. So the tools are available, as I told you, like a scikit-learn, but each and every technique can be solved with a different different method. Okay, so suppose if you want to if you want to remove irrelevant features, so you don't need to use any kind of a tool. You can just use the drop function of pandas, and you can drop those features. So what kind of a tool you need? Okay, so it's just like if I say one statement in Hindi, so जो काम सुई से होता है, you don't need you don't need to use sword for that. Okay, so it's as simple as that. So removing irrelevant feature means you just need to drop some columns. So for dropping a column, you can use simple drop function of pandas. So why you need maybe any specialized tool for this? Okay, so you don't need maybe any specialized tool for this. Okay, in a similar way, so the second technique is handling the missing data. Okay, so there is so missing data is again a kind of a noise. So missing data means okay, so I think I took that example yesterday, so yesterday also, at a time of conducting survey, or maybe at a time of scraping data. So there may be maybe a lot of possibility that people can hide their some of the, like, their confidential information or something, and in that way you end up creating a data frame where there may be a lot of missing values. Okay, so if there is lot of missing values present inside your data set, so you are not able to process further. Okay, so you're not able to process further, and maybe if somehow if you're trying to process further, so there is a huge possibility that you are not getting an accurate prediction, or you're getting an accurate result. So what all you can do is you can, sir, is it possible to develop ML system if we don't have any historic data? No, not at all, man. Without as I told you, data is a kind of an oxygen for a machine learning system. So without oxygen, as we can't like live without an oxygen, so you can't take a single step without an like a data. Okay, so and this comes into the definition itself. So based on the previous information, based on the past historical data, based on the past experiences, we are able to learn something. Okay, so okay, so for handling okay, so now you so this is a way of, like, maybe there is a possibility of a missing values inside your data set. Okay, so now you need to solve this problem. You need to solve like that ambiguity. Okay, so you need to so there are two way to solve this problem. One way is to drop the null values. Okay, so like in yesterday's session we dropped the null values. The simple answer is be patient, guys. Please. Okay. There again, there is a, like, a function is null. Okay, so there is a function through which you can check whether the null values or not. Okay, I'm going to show you the practical implementation, but please be patient. Okay, just try to understand first. Okay, what how you are able to create a missing values and how you are able to solve the problem. Okay, I'm going to show you everything, that what kind of a tool you are using, and what kind of function you're using to solve that problem. Okay, don't worry. Fine. Now to handle a missing values, there are two ways. First, you can drop the missing values. Okay, so you can drop like maybe that column where there is a missing values. Okay, so but there is, like, some kind of one criteria which is set for this. Okay, so maybe if there is more than 70% of null values. Okay, so if your column contains 70% of null values, or more than 70% of null values, so yeah, from our from the bookish knowledge, or from the concept, from the theoretical point of view, you can drop that column. Why I'm saying from the bookish knowledge or from the theoretical point of view? Because once you start creating your model, okay, so because I'm having maybe 3.5 years of an experience in doing all these things. So once I start creating a model, once I start making a model, once I start making a comparison, so I'm able to understand, I'm able to realize that everywhere I can't go with with this step. Okay, so I can't drop the null values everywhere. Okay, yes, some of the place I can definitely drop the null values, but I can't drop it everywhere. Okay, so if there is so theoretically it was saying that if more than 70% data is missing in a column, so you can drop that, but it is based on your experience. Okay, so as long as you are dealing such kind of data, so you are able to you are able to realize, okay, so where I need to drop the null values, or whether I am not going to drop the null values. Okay, so you are one way is to drop, another way is to imputation. Okay, so imputation means you're trying to impute those missing values with any other value. Okay, so in place of that missing values, you can impute that missing value with with any other value. Okay, so the very famous technique or the very popular technique for the imputation is a mean median mode imputation. Okay, so mean median mode means you can impute the missing values to the central tendency of data. Okay, so mean median mode is is called a central tendency. I think I used this term yesterday also. So mean median mode is a central tendency of is represent the central tendency of your data. So you can impute the missing values with a mean, median, or mode. Okay, so this is a popular technique which is available. Although you can try to impute the null values with any arbitrary value also. Okay, so arbitrary value means 0 or 1 or maybe any other value which you want. Okay, so maybe you are aware of the knowledge, you have like maximum knowledge, or you have enough of knowledge to understand that maybe in this place maybe so in place of null it may be a 0. Okay, so if you have that knowledge, if you have that much of knowledge about the data set, so yes, you can fill any other value based on your choice, based on your knowledge. Okay, otherwise if you don't have any knowledge, so a simple concept or a simple way to impute the null values is mean, median, or mode. Okay, and yeah, just maybe in 1 hour I'm going to show you that those things, so don't worry. Now the third step is feature transformation, data transformation or feature scaling. So scaling means you try to scale all the features into the similar scale. Okay, now I'm going to take these 3 steps, this last 3 steps into like on my paper. Okay, then only you are able to understand. Okay, so scaling means you are trying to reduce the difference. Okay, so maybe what I'm trying to say, so suppose one of your feature, maybe feature 1 and feature 2 is present. So suppose in feature 1 you are having a data in this way. Okay, so maybe a 2 3 1 4 5 7 8. Okay, so you are having data in this format. Fine. Now in feature 2, suppose you are having a data in this format. Okay, so maybe 100 again, maybe 1,000, or maybe 120, maybe a 720, or maybe a 500. Okay, just remove this. Okay, so now here we have a data in a like units. Okay, so in feature 1 all of my data is present in a units, and in feature 2 all of my data is present in a hundreds. So scaling means we try to scale down, we try to bring all my data into the similar scale. Okay, so what I actually want to perform is I want to reduce this difference. Okay, so there is a difference. Okay, so a 99. So I want to reduce this difference. Okay, so what I can do, what kind of I think if I ask you guys also, you are able to perform. Okay, so if I ask you how you are able to reduce this difference. Okay, so yeah, you can answer that you can try to apply a square root on both the side. Okay, so you can apply that square root. So after applying a square root, it becomes 1 and it becomes 10. Okay, so the difference is reduces. Even if I try to apply a square root again, so the difference become very less. Oh, sorry. Okay, so the difference has become less. So yeah, I can apply a square root. Even I can apply a log function. So but yeah, here I can't apply a log function. So yeah, but in some cases, suppose if this is this present in a like maybe in form of a tens, and this present in form of 1,000. So yeah, you can apply even a log function to minimize the distance. So these are all this we call a transformation. Okay, so we call it as a square root transformation. Maybe if you're trying to reduce the difference with the help of log, so we call it as a log transformation. Okay, so transformation simply means that we're trying to bring our data into the similar scale. Okay, and that help us to build like a perfect model. Because if we try to if we try to fit the data like at a time of training, if you try to fit a different scales of data, so it will take like a lot of computational power. Even if it will take like a lot of time to like a compute. Okay, so we always try to scale our data into the similar scale. We are always trying to transform our data into the similar scale so that it becomes easy, is smoother to proceed. Okay, to make actually we're trying to make our data set ready to build a perfect model. Okay, so if we try to feed like a perfect data, if you try to feed like proper data in a proper format, then only we are able to get a better result. Okay, so that is why we always try to we try to solve most of the problems. Okay, so these are kind of like ambiguity or something, so we just try to solve it by using a square root transformation or by using a log transformation. Although there are like two popular techniques to solve this problem, to bring down your data into the similar scale. So there are two popular technique, maybe you can say mostly used techniques, and those are called a normalization and standardization. Okay, now I'm not going into the depth of normalization and standardization. The very simple idea of normalization, you are trying to bring your data into, so you are trying to normalize your data. Okay, so normalization means you are trying to make your data to form this kind of a distribution. Okay, so this is what we call the normal distribution graph, where you have a bell-shaped curve. So you're trying to bring your data into a normal distribution form, so that what happens after a normalization, so all of your data, okay, so all of your data, it comes into this scale. It comes into this range between 0 to 1. Okay, so all of your data comes into this range 0 to 1. Okay, so this is what happened after the normalization. Okay, so if we apply a normalization, so all of my data is comes into this range 0 to 1. Okay, so this is also kind of technique, and with this we are able to solve this problem. We are able to transform our data, we are able to scale our data into the same scale. We are able to bring our data into the similar scale. So yeah, you can apply a normalization, and the formula for the normalization. Okay, so yeah, definitely you need to understand much right now, but yeah, you can write down the, like, you can understand the formula. So the formula is pretty simple, pretty easy to understand. Okay, so this is the formula for normalization. Sir, is the output is accurate if you transform the data? Yeah, definitely. Yeah, sure. So there is no if you the feature engineering, we are trying to apply the part of feature engineering only on the input data. We are not going to disturb the output data, means the output variable or the target variable. Okay, so we are trying to make our data set ready to build a model. Okay, because suppose if you apply any kind of equation, okay, so each and every machine learning algorithm contains an some kind of a mathematical equation. Okay, so maybe it may be an equation of line, it may be an equation of plane, it may be an equation of circle. So each and every if you like fit a proper data onto that equation, so you are able to get a more accurate result. Okay, so if you fit the this kind of a data, maybe some data is in the form of 2 3, and then another data is in the form of 100, and then another data is in the form of lakh or 2 lakh. So yeah, it will take like a lot of time to compute, and maybe it may possibility that it will not give you the correct result or maybe accurate result. Okay, so with the help of this kind of a techniques, maybe a square root transformation, log transformation, normalization, you are able to achieve a better accuracy there. Okay, you just need to realize that at what place we need to apply this. Okay, now for this you need to learn the like statistical concept also. But yeah, as I say that we don't have that much amount of a time that I can go into the depth of this. But yeah, these are the techniques through which you can scale your data into the, you can bring your data onto the similar scale. Now you can try to explore this knowledge, you can try to explore the knowledge of normalization, you can try to explore the knowledge of standardization, and you can then realize that at what place I can apply this normalization, at what place I can apply this standardization, and at what place I can apply this square root and a log transformation. Okay, now in case of standardization, so similarly like in this case your data comes into the range of 0 to 1. Now in case of standardization, your data comes in such a form that the mean of your data becomes 0 and the standard deviation of your data becomes 1. Okay, so this is what happened after applying a standardization. And this is what happened after applying a normalization. Okay. Okay, guys. Now the next technique in a feature engineering is called handling a categorical variable. Okay, so as I told that in case of every machine learning algorithm is having some kind of what you call like some kind of a mathematical equation behind it. Okay, so some kind of a mathematics related to linear algebra, or maybe related to statistics on probability, maybe related to calculus. So each and every machine learning algorithm having some kind of a equation, some kind of a mathematics behind it, and you can't pass categorical data. So categorical data means suppose you have one column as gender, and inside a gender you have male, female, and transgender. So you can't pass like a male, female, and transgender data from that equation. So suppose if I take a very simple equation at one place like a linear regression, which I am going to tell you in this session itself. So the linear regression data is having the linear regression equation is having y equals to mx plus c. So you can't pass like male or female at this place. Okay, it will not going to give you the result if you're trying to pass a male and female. You can pass any value, you can pass any numerical value, maybe 0, 1, 2, 3, or anything, but you can't pass a male or female from this from there. Okay, so you need to handle the categorical variable. So handling categorical variable means what? You need to convert this like male and female maybe into a 0 or 1, or maybe anything you just try to convert it into a numerical one. Okay, so you need to convert your categorical data into the numerical feature. Okay, so for that you have two famous technique. One is called one hot encoding, and another one is called label encoding. Okay, now I will make you understand that what happens are just very easy things to understand. You can understand in this in just 5 minutes itself. So suppose what happens inside of one hot encoding. So maybe I'm having data in this way, gender, and inside a gender I'm having like male, then I'm having a female, then again I'm having a male, again I'm having a male, maybe, and then female, then transgender, then maybe a female, then maybe a male. Okay, so this is all like a data which I'm having right now. Now what happened inside of one hot encoding? So one hot encoding creates three separate columns, because we are having three distinct category. So it creates three separate column. So it creates G of M, means a gender male, then it creates G of F, gender female, and then it creates G of T, gender transgender. Okay, so if there is a male, so it put one at a place of GM, and rest of the column becomes 0. Similarly here it in place of female it becomes 1, rest of the column becomes 0. Similarly in here. Okay, now I think you are able to understand that how I am going to fill these columns. Okay, so 0, 0, 1, then again 0, 0, 1, then maybe a 0, 1, 0, and then 1, 0, 0. Okay, so so now this is your new column, and now what you're trying to in one hot encoding what happens? So one hot by using one hot encoding, so now you have a again pandas is having a tool to implement this. So you can use pandas.dummies function to implement this kind of a thing. And pandas so what did this pandas.dummies do? So it just drop this column. Okay, so you are able to drop this gender column, and now you have these three new columns. Okay, so this is what happened inside of one hot encoding. So you are able to convert your categorical data into the numerical one without without losing any without losing a single information. Okay, so this is what you can do with the help of one hot encoding. Now what happens inside a label encoding? So if I talk about a label encoding, so in case of label encoding, again you have a gender column. So now you in a label encoding there is no alternative columns are created. Okay, so in a label encoding it simply convert it simply make male as 1, make female as 0, and make transgender as 2. Okay, so in this way, so in this way, it is able to create it is able to convert a categorical data into a numerical one. Okay, so with the help of label encoding also you are able to convert your categorical data into a numerical one. Now the advantage and disadvantage is here you are trying to develop data with a like some kind of a logic. Okay, so there is some logic behind it. Here you create a data without having any kind of a logic. So this is like a kind of advantage and disadvantage. Now the disadvantage of this pd.dummies is you create extra columns. Okay, so this increases your dimensions. Okay, so maybe at some point you don't want to increase your dimension because it increases the complexity as well. Okay, and here there is no extra columns are created, so there is no problem of maybe a extra dimension. So yeah, now it's up to you. It's depend upon the kind of data you are having. So suppose maybe if you are able to see, okay, so if I try to use maybe one hot encoding, so the complexity maybe increases, so you drop the idea of using one hot encoding, and you can use label encoding. And maybe if you are able to see, okay, so now okay, so if I using a one hot encoding, so there is no there is no effect on a complexity, so you can go for the one hot encoding. Okay, fine. Now again, if I come to my PPT, okay, so these are the like 4 techniques, and the last technique through which you are trying to solve your problem. Oh. Fine. So the last is outlier detection. Okay, so outlier detection means what? So I think someone of you asked this query yesterday session itself. So outlier means a kind of an exceptional data, like a kind of a odd one out data. So suppose in feature 2, if you have like okay, so I intensely put 1,000 over there. Okay, so all of your data is like in 100, 200 or something. Then accidentally there is one data which is like 1,000, or maybe it may be at 10,000, it may be at 12,000. Okay, so that is what you consider as an outlier. And now there is a like kind of a formula or kind of a rule which is available to solve this kind of a problem. Okay, to detect an outlier. Okay, now what are all like kind of a rules or kind of a formula which is available? So that is called like empirical rule. Okay, so based on like your knowledge in a statistics, you can solve this kind of a problem. Okay, now okay, I think if you don't aware about the like empirical rule or something, so I give you a very good example to understand. So suppose if I ask you to conduct a survey in your place. Okay, so maybe in your place I want you to conduct a survey maybe in your city, and I ask you to like conduct a survey of maybe a people in between the age group of 20 to 30. Okay, so I ask you to conduct a survey of a person who is in where the age is between 20 to 30. Now and just collect like data of their weight. Okay, so just ask them what is their weight, and just collect that information, and then plot that information, just plot a graph of that weight. Okay, so if I if I talk in a general sense. Okay, so if I talk in a general sense, that what may be the possible weight of a person if his weight is in between 20 to 30. So your answer you can say that the weight may be maybe in between. So most of the people, okay, so maybe a 60 or 80 sorry 70% of the people is having a weight in between 55 to 85. Okay, so in the age group of 20 to 30, maximum people are having this weight. Okay, according to me, according to like my general knowledge, you can check based on you. So you can say maybe a 50 to 80, you can say maybe 60 to 90. Okay, so suppose I just take a two hypothetical value, 55 to 85. Okay, and this is a normal tendency. This is like a normal graph. If I try to plot the weight of people like if I try to plot a graph, so I think this is a normal tendency. This is a normal this is a normal range, okay, in between 55 to 85. Now there are few people and so 70% of the population, okay, so definitely 70% of the population is going to fall in that category. Okay, I think every one of you agree with this point. Now there are few people who is maybe having some kind of a deficiency or maybe some kind of a weakness and all, and because of that their weight may be a 40. Okay, so suppose if your age is 20 or maybe a 22, so you can't have a weight like you can't find like maybe more people with the weight of 40. Okay, so it may it possible only if the person is having some kind of a disease or maybe some kind of maybe a kind of like a health issue or maybe an like a lack of nutrition or something, then only is having a weight of 40. Okay, now if I okay, and the second possibility is there might be some people who's there may be a fat problem, and again maybe because of some disease their weight might be a 120. Okay, so this the value 120 and this the value 40 is considered to be an outlier because they are very far away from the normal tendency. Okay, so they are not falling into the graph of normal tendency. They are not falling into the graph of like where like maybe, okay, so suppose if I take even a 45, or maybe if I suppose if even if I take a 50, and at that at right side, if suppose if I even take a 100, then so in between 50 to 100 I can say like 90% of the people lies. Okay, or maybe a 99% of the people lies, but there are like only few people whose weight may be 40 or maybe a 35, and there are only a few people whose weight may be a 120 or 130. Okay, so these people are not falling into the like in a normal curve. They are not comes into the graph of a normal people. Okay, they are like they are away from the normal people graph. Okay, and these peoples are considered to be an outlier. Okay, so these peoples are considered to be an outlier. Okay, so I think you are able to understand. So this 35 and the 125 is considered to be an outlier. Now in our data set, if we have this kind of a data, okay, so suppose if we have this kind of a data, so we must try to detect like, so detection means we must try to check, okay, so whether my data set is having an outlier. So we are trying to maybe compute a formula, or maybe you have like kind of visualization tools or libraries like a Seaborn which we learned yesterday. So by using that library you can make a plot. So there is one plot which is called, I think, a box plot. So by using a box plot you are able to see whether your data set is containing an outlier or not. Okay, and then if you have an outlier, so what you can do is you can remove that outliers, or maybe if you don't want to lose an information, so you can try to bring that outlier into on your normal scale. Okay, so that is like that are like the things which you can do. Okay, so these are like 5 key point or the key techniques which you need to follow at a time of feature engineering. So okay, so after like a feature engineering, what we need to do is we need to prepare our data set for modeling. Okay, so before go for the modeling or before selecting the best algorithm, what we need to do is we need to prepare our data set. We need to like make a proper preparation of my data set, so that we can you can fit your data onto the algorithm and you can go for the modeling. Okay, so what I mean by the data preparation, so you have so you have a data in this format. Okay, so now this is a proper data frame which you are having. Okay, so you have an age, you have a gender, you have a weight, and now suppose you need to predict an height. Okay, so these three age, gender, and height is your features. Okay, so this three columns is your feature. Okay, and you can also call it as an input variable. So these three features are the input variable, and the height is your output data or the target variable. Okay, now you have 150 observations. So 150 observations means data of 150 people, or maybe a student. Okay, so student, this is example of primary school students. So you have a data of 150 students, and you have this information. Okay, so you have this all this information. Now the very first thing is you need to split the data into two format. Okay, so first you need to split the data into a feature. So suppose you need to create one variable where you need to preserve all of your features. Okay, means your age, gender, and weight. Okay, so feature F. And then you need to create another variable Y where you need to preserve this height. Okay, so this X contains a features and this Y contains a output, or you can say a target. Okay, now you need to so now when so you need to train your data. Okay, so for training, what you can do is, so there are like two things. Okay, so what you can do, you can take all these 150 observations for the training purpose. Okay, so you can like train your model, or you can build a model on the basis of 150 observation, on the basis of this 150 observation, or on the basis of 150 data. And then you can ask maybe you can go for the deployment. You can ask maybe your client, or maybe industry. Yeah, so you can deploy my you can use my model. But uh, this approach is not good, because it may possible that your performance is not good. Okay, so it may possible that your accuracy, or maybe your performance is not good. So what you need to do is you need to evaluate the model first. Okay, so you need to evaluate what you made. Okay, so whatever model you have made, you need to you first need to evaluate from your end. Okay, so you need to evaluate the performance from your end. Okay, so whether my data performing good or not. So for that purpose, you need to break your data into two sets. One is called training and another one is called testing. Okay, so you need to break your data. Can we use as yeah, I told you that is not necessary to remove the outlier. I told this thing, yeah. So maybe if you don't want to lose the information, maybe that outlier contains a very important information. So you, so it's not it's not necessary, and in every case you don't need to remove the outlier. Yeah, you can be use those data by making data. Yeah, you can make that. You can even you can try to concise that data by following some. Approach, or you mentioned the data transformation, so you can use the standardization to bring your data maybe onto the same scale. Okay, so in that way you are able to solve the outlier problem also. Okay, so yeah, it's not necessary to remove the outlier because it may contain a very important information. Okay, so now here what we need to do is we need to break our data into two parts. Okay, two sets, you can say. So one set is called a training set, another set is called a testing set. So what I mean by a training and testing set, so suppose you have this 150 observations. So what you can do is you can like take 70% of your data for the training purpose. Okay, so training purpose means you train like an algorithm. You try to fit your data on the machine learning algorithm. You try to fit 70% of your data. Okay, not 100%. 100% means all 150 observation. So you just try to take maybe 105 observation for the training purpose, and then remaining 45 observation for the testing purpose. Okay, so at a time of training, you try to train your data set. You're trying to train your model. You apply some kind of a machine learning algorithm, and you are trying to train your model. And on the remaining 45 data, on the remaining 30% of your data, what you try to evaluate your model. Okay, so whatever the model you build based on the information, based on the training information, training data information, you are trying to build a model. And then on the 30% data, so that 30% data is totally unseen. Okay, so that 30% data is totally unseen because you never seen those 30% of data. So you are trying to evaluate your result on the remaining 30% of data. And now if you're happy with your result, if you're happy that yeah, my model performance is good and I'm able to achieve a good accuracy or good result, so you can go for the deployment. You can go for you can ask your client to deploy, or you can ask you can take your model to the industry and ask them to deploy the model. Okay. Sir, output is based on input. Any changes in variable will impact on output accuracy. Any changes? So what kind of a changes we are doing? We are not we're not doing any kind of a changes. So any feature engineering technique or whatever the technique we are using, you're not changing the input variable. Even if you're trying to scaling at a time of scaling also, the original thing is not going to change at all. You're just trying to scale onto the similar scale, so the value is not going to change at all. Means the main thing inside that variable is not going to change at all. And even some kind of a change is bring a positive result for your output. Okay, so suppose if you're talking about the categorical variable, so those categorical variable is going to affect you are not able to even fit your data into the algorithm. Okay, so with the categorical data, likewise, I take an example of y equals to mx plus c. So you can't fit male and female in place of x. Okay, it must be any numerical value. So you need to change that. It will not going to affect your result. Okay. So fine, here what you can do is okay, so what you can do is you need to break your data into the two sets. One is training. So always remember, training is so the training data is used for what you can call, okay, so training data is used for the building a model or for training an algorithm, and the testing data is for the evaluating the result. Okay, so whatever the model you build, you need to evaluate your result. You need to evaluate whether the model which I build, or whether the whatever the concept which I use, whether it is giving me a correct result or not, whether it is giving me an accurate result or not. Okay, so this is what you need to check at a time of testing. Fine. Okay, so and is this way you prepare your data set for the modeling. Okay, so now let's jump on to the next slide. And okay, so here okay, so here we I just take a 5 minute break. And so if you guys have any like a query or something, so you can ask, and even you can also take a break of 5 minutes. So just give me a 2-3 minutes. I will come back like in just 2 minutes. Testing data will be hypothetical? No, not at all. Why testing data is hypothetical? Testing data is not going to have, testing data is your like remaining 30% of your data, which is as I told that out of that 150 observation, which you are able to see that there are 150 observations are there. So out of those 150 observation, if you take like 70%, so you take only 70% data for the training, and remaining 30% data is for testing. So that the remaining 30% data is there. Okay, so if you remove 70% from 150, so it becomes 105. So 45 data is still available. Okay, then another, sir, can we get libraries along with Anaconda application, or we have to download libraries separately? Okay, lot of libraries are available with the Anaconda application itself. Okay, but like a Plotly. Okay, so if you're doing this thing on offline, okay, so I'm doing like online with the help of Collab. So Plotly is available online, but if you're doing it off online, so maybe you need to download Plotly. Okay, but it's not that much typical. Okay, you only need to use exclamation mark, and then whatever the library you want to download, you just need to write pip install and then name of the library. Suppose if you want to install Plotly, so pip install Plotly, and before pip you need to put exclamation mark. Simple. And even suppose if there is any library where you are stuck or you are not able to find, you are not able to download, so just try to put the same thing onto the Google, and just click on the very first link. You are able to then you are only need to copy that installation instruction, and you can paste the same statement over there, and you are able to download. Okay. Whereas most of the applications are available along with the Anaconda itself, like Pandas, NumPy, these are available along with the Anaconda itself, scikit-learn and all. Sir, as informed earlier, we are changing the parameter of the input variable to obtain desired output. As output is based on input, any change in the input variable will have impact on output. Further, the input depends on individual working on the data, in which case how the accuracy of the outputs is to be determined. How the parameter of input variable okay, when you are changing the parameter of input variable, parameter is totally a different thing, and you are changing you are just suppose I don't know that which specific technique you are talking about. Maybe if you're talking about a scaling, or if you're confusing with the scaling concept or lot, so simply okay, so just don't use that scaling technique at a time of doing. Okay, it's not necessary that everywhere you need to use that scaling like a transformation thing. And even that scaling is not going to change anything inside your variable. Okay, so it is not going to change any kind of information. Okay, the information is remain same as it is. Okay, and the accuracy of the output is going to determine as I told you now, that you are going to break the data into form training and test. So from your training data you get some predicted value, and that is what I'm going to explain you right now. Okay, so don't worry about this in which case you are able to understand in just few minutes. Okay, so I think yeah, now this is the important point. This is the important stage. You need to select the algorithm. So the very first thing which you need to check whether your problem statement is fall into the category of supervised or unsupervised learning. Okay, so this is the first thing which you need to check. Now if it falls into the category of supervised learning, so the second thing which you need to check whether it is a regression problem or whether it is a classification problem. Okay, so now I have written over there that I have mentioned some of the algorithms, although there are more number of algorithms are present, but there are some algorithms which you can use in case of a regression, like a linear regression, polynomial regression, support vector regression. And in case of classification task, you can use logistic, KNN, decision tree, random forest. Okay, So these are the very basic, and these are some basic and what you call fundamental algorithms, or popular algorithms, which you can use in case of a regression and a classification problem. Now I'm going to explain you the linear regression. We don't have to time to explain maybe like more complex algorithm. So I'm going to explain you the linear regression. Along with that, I'm going to give you the idea of decision tree, because this both of these algorithm is for the different kind of a problem. So linear regression is to solve the regression task where your target variable is like maybe any number, and in a decision tree, with the help of decision tree, you are able to solve the classification problem. Okay, so where your target variable may be classes. Okay, and we are going to I'm going to explain you this linear regression I'm going to use in practical implementation a decision tree, because these two algorithms are highly interpretable means you are able to see that what is going on inside an algorithm. Okay, in rest of the algorithm, the mathematics is like so complex that you are not able to realize, you are not able to generalize that what is going on inside that. Okay, but in the decision tree, you are able to generalize, you are able to realize, okay, so this is what going on inside this algorithm. Okay, now okay, so I think in yesterday's session also someone asked me about a pattern or maybe something. So a lot of idea is going to clear in this linear regression intuition. Okay, so linear regression is nothing but you are just trying to find out the best fit line. So you are going to follow your ninth class or maybe I think a seventh or eighth class study, the equation of line. Okay, so with the help of equation of line y equals to mx plus c, you need to find the best fit line. Okay, so best fit line means the line which is best fitted on your model. Okay, so you need to find that kind of a line with the help of the same idea, the same equation y equals to mx plus c. So generally you only try to make a prediction by simply computing the weighted sum of the input feature, means your x means all of your features, and plus the constant term. Okay, so constant term is your y-intercept. Okay, so the c, so here that constant term is called bias. Okay, so you're going to find out the weighted sum, means like mx plus c. Okay, so yeah, it is very easy to understand and interpret. Fine, now I am going to give you the idea of linear regression. So guys, just be with your pen and paper so you are able to understand it much better way. Even you need to solve some like calculation. Okay, so fine, to make our calculation easy, I am going to use a very simple example, a very like a very less amount of data. So suppose we have like x means our features, and we have height. Okay, and our target variable is weight. Okay, and so based on this height, we need to predict the weight. Okay, so this is what the objective of my objective for this linear regression task. And the weight is weight is a number, so that is why it is called a regression task. Now, so suppose if the height is 5.6, the weight is 60. So I just collect some observations, some like a data of a student. So maybe in corresponding with 5.8, I have 62. Maybe in corresponding to 5.4, I am having 59. Maybe in corresponding to 5.9, I am having maybe what you like 67. Then in corresponding to 6.3, I'm having maybe 75. And then yeah, that's it. That is fine. Okay, now my job is to what? My job is, so suppose I have this 5 observation. Suppose any new students come whose weight maybe 6.4. Now I need to predict what is a height of this student. Okay, so this is what my problem statement is. Okay, so the very first thing is and this is the objective of linear regression. Okay, so suppose your data set is splitted in this way. Okay, so maybe this is this is your data set. Okay, so this is your like a data set. So it is splitted in this way. These are all your observations, although we are having just 5 observations, but I just make like for your like understanding, I just make like maybe more observations over here. So I want to find out a line. I want to find out that line which fit on this data set. Okay, so definitely this is not going to touch each and every point, but I want to fit that line which is having a minimum distance from each point. Okay, so maybe the line should be like this, or maybe the line should be like this, or maybe the point line should be like this. Okay, so I can draw a multiple line and I can check, okay, which my objective is to make such that line. My objective is to make that line which is able to touch most of these data points. Okay, and that particular line is called the best fit line. Okay, so this is what the objective of best fit line. Okay, this is what the objective of this linear regression. Okay, now okay, so you guys are able to solve this problem. Okay, so what you can do is, so here we are not going to write y equals to x plus c, because this is a standard equation of a line. So in this case we need to write y hat means predicted y. Okay, means a predicted weight, because whatever the weight we are going to find out, that is a predicted weight, that is not an actual weight. Okay, so we are how we are able to find this predicted weight. So for that we are going to represent this thing in this way. Okay, so beta x plus beta naught. Okay, so this beta is called the weight. Okay, this is corresponding to the slope of a line m, and this beta naught is called the bias. Okay, so bias is corresponding to this this c, y intercept. Okay, so in terms of linear regression, this is what this is how we denote our equation. Okay, maybe if you are having more number of features, so it become a beta 1 x1. So in our previous example we have 3 features, so it become beta 1 x1, beta 2 x3, beta 2 x2, and beta 3 x3 plus beta naught. Okay, now we need to calculate the beta and beta naught on the very first place. So how we are able to calculate this beta and beta naught? So a very simple mathematics you can apply. So 60, so we have a weight, and then you have a beta, and then x 5.6, then beta naught. Okay, so this might be your first equation. Now just take another value 62, then again beta 5.8 and plus beta naught. So this might be your second equation. Now because so I think every one of you aware about this kind of a mathematics. Okay, so every one of you in your childhood is learn about elimination method, and or yeah, definitely you can solve this equation to find out the value of beta and beta naught. Okay, so who out of this maybe a 35 or 39 students who think that yeah, they are expert in mathematics, so yeah, you can give me the value of beta and beta naught. Okay, so yeah, you can do the calculation even if you are not able to perform a calculation in fast. So I will tell you the value. So this value is 10 and this value is 4, right? Because I already calculated it, otherwise it will take a time. So beta is 10 and beta naught is 4. Now try to okay, so maybe okay, so you can guess maybe this is your a training data, and now this is maybe your testing, this one data you want to test. Okay, this one value you want to test. Okay, so suppose if you fit 5.4, now just check the predicted y, now just check the predicted height. Okay, so at 5.4, just try to check the predicted weight. Okay, so it becomes 10 into 5.4 plus 4, and the result is 58.
It is 6.4.
But if you see the actual y is what? The actual y is 59. Okay, so the actual weight is 59 and the weight which you predicted is 58. Okay, so now someone asking that how you are able to determine an accuracy. So this is how you are able to determine your result. Okay, so this is an error. Okay, so the actual weight is 58, but the actual weight is 59, but your predicted weight is 58. Okay, so this is what we call a error. Okay, so now how you are able to calculate an error? So in case of a regression, you try to calculate an error with the help of mean squared error, and the formula for mean squared error is half of y minus y hat. Okay, so half of y minus y hat means 59 minus 58, and then whole square, and it becomes 0.5. And this is what my objective in case of a linear regression task. Now I want to minimize this weight. Okay, although this weight is very minimum, but in a like in a real case scenario. Okay, so wherever you have maybe a 40 or maybe a 50 data or maybe 100 data, and then when you compile this error, when you combine all these errors, so it becomes the value becomes very high. Okay, so this is our objective, that we want to minimize this error. We want such kind of okay. And how we are able to minimize? So this is our optimization problem. Okay, so in case of a linear regression, this is our optimization equation, or you can say optimization our optimization equation, that we want such beta and beta naught. So we want such beta and beta naught. Guys, please unmute yourself. Please mute yourself. Yeah. So we want such beta and beta naught which can minimize our error. Okay, so maybe we are having n number of values. So this is what we want to minimize. Okay, so uh, it may be yeah. So beta 1 x1 plus beta naught minus like my actual y. Okay, and divided by n. So this is my optimization equation in case of a linear regression. Okay, so I want such beta and beta naught. Okay, because this beta and beta naught is my parameter. Okay, so we want such beta and beta naught which can minimize this value. Okay, because I want this value to be very close to 0. Okay, so this if this value is very close to 0, definitely in this case we are not trying to find out an accuracy, we are just trying to find out an error. So if our error means a loss. Okay, so if our loss is minimum, then definitely we can say that the performance of my model is very good. So I'm able to deploy my model, because the error in my model is very near to the 0. Okay, it's just negligible. Okay, so if the error is negligible, if the loss is very low, if the error is negligible, so yes, I can deploy the model, I can use it for the production. Okay, so this is the objective of and this is the objective of any machine learning algorithm. Okay, we are trying to reduce an error, and we are trying to achieve a maximum result. We are trying to achieve a good result. Okay, so this is a meaning of a machine, this is a meaning of a learning. Okay, so we are trying to find out a relationship in our data, and we are always with the help of experiences, with the help of data, by applying maybe by reducing a noise or by adding some information, we always trying to reduce an error, and we are always trying to achieve our a better accuracy, a better prediction, a better result. Okay, so in this case we are not dealing with an accuracy, because this is a case of like a regression. So here I am trying to find out a mean square error, or you can say a root mean square error. So you can put like a square root. You can try to find out the square root of this value. Okay, so it becomes a root mean square error. So this mean square error and this root mean square error should be very minimum. Okay, so if it is very near to 0, if it is minimum, so you can say that yes, the performance of my model is very good, and yes, I am ready to deploy my model. Okay, so this is a case of a linear regression. Now if I talk about a decision tree, okay, so here itself I can I can talk like a decision tree, because I think in a PPT you are not able to understand.
So are you showing a screen? It's blank screen for me.
No, this screen is visible, no?
Yes, sir, it's blank.
Is it blank for everyone?
No, I don't think.
Yeah, it's visible, man. I just turned my page and I didn't write anything in the new page. Otherwise, the screen is visible at all. Yeah. So
So
this
I'll
is the
join again then. I'll leave and join again.
now if I talk about a decision tree. Yeah, thank you. So now if I talk about a decision tree, okay. So I just give you a glimpse of one model from the regression and one model for the classification. Okay, definitely I'm not going into the depth of mathematics because it will take a time. But yeah, if I think you are able to get the intuition. Okay, so what is linear regression is all about. Now, in case of a decision tree, what we are trying to do, so decision tree is like a highly interpretable model. And why it is highly interpretable? Because it follows the approach of if else, it is a kind of a if else classifier. Okay. So I think every one of you, if you are having maybe a general programming background also, so you know the meaning of if else. Okay, so maybe if one condition is false, so you are trying to follow the another you are trying to check the another condition. If another condition is again false, so you are trying to check another condition. Okay, and if all the conditions are false, then you are trying to print the statement which is inside a else part. Okay, so similarly, so this algorithm, this decision tree algorithm, is going to follow the same approach, the same if else kind of an approach. It is going to be followed. Okay, so suppose there is one data set, a very famous and very like a kind of a old data set, which is called Irish data set. Okay, now inside a Irish data set you have three classes. Okay, so you have three classes. So your yi is having three classes. Okay, so 1, 2, 3. So these three classes is nothing but, so there are three kind of iris flowers. Okay, so iris is kind of a flower. Okay, so the three kind of iris flower is existing in this world. One is maybe a setosa, two is versicolor, and three is virginica. Okay, so I just write the name over here so that if you are trying to check, so you are able to understand what I'm trying to make you understand. Okay, so maybe a second, two belongs to a versicolor, and 3 belongs to a virginica. Okay, now xi, okay, means your xis means your features. So what are all the features? So they are sepal length, petal length, sepal width, and petal width. Okay, so I think you must aware about at least this much of knowledge. Okay, so sepal length, petal length, sepal width, and petal width. Okay, so sepal these are like a key feature inside any kind of a flower. Okay, so any kind of flower existing in this entire world, these are having some these are like some basic features available inside that flower. Okay, so sepal length, petal length, sepal width, and petal width. Now based on this feature, we need to make a classification model where I am able to classify whether so suppose if any new flower comes into the existence, so we need to we are able to classify. Okay, so that flower is belong into the category of setosa, or whether it belongs into the category of versicolor, or whether it belongs into the category of virginica. Okay, so now how a decision tree help you to bring to make this kind of a model. So suppose a petal length is a kind of a feature which is like most useful feature, maybe a most important feature. Okay, just assume. Okay, so just assume that petal length is kind of a most important feature. Okay, so what you can do is here this kind of a thing we need to follow. Okay, so suppose you make some kind of a graph, and from this graph you have a knowledge that if my petal length is lesser than some value, okay, that value may be a. So if my petal length is lesser than a, so my flower will always be a setosa. Okay, and if petal length is not okay, so sorry, so you need to check the condition. So if this condition is true, okay, so if this condition is true, so my flower will definitely be a setosa. Right, now if this condition is false, so I will check with different another condition. So what may be the another condition? Maybe the other condition may be a petal width. Now, if petal width is lesser than some value b, so again I am going to check true or false. Again I am going to check. So if this condition is true, so my flower must be a versicolor, a 2. Okay. And if this condition is false, so maybe my flower must be a virginica. Okay, so hypothetically I made this, but this is the same approach what your decision tree is going to follow. Now this node is called the root node. So from where you start, that node is called the root node, and the AND node is called the leaf node. Okay, so AND node where you are able to make a result, or whether where you are able to make your prediction. So that is a leaf node, and this node, okay, so where you again try to make a condition. So this middle node is called the internal node or the child node. Okay, and how why I try to say that this follow if else approach. So yes, you can try to make it in a form of a pseudocode, that if my petal length is lesser than a, so my I is 1. Okay. Then elif. Okay, so in Python you have elif, not else if. Okay, so if elif my petal width is lesser than b, so yi is equals to 2, else yi is equals to 3. So this is a simplest approach, or this is the very simple idea which is follow inside this decision tree classifier. Okay, so and that is why it is highly interpretable, and you are able to see that what is going on inside. Okay, although for selecting, okay, so where the mathematics comes into the picture, to select this root node. Okay, so we are not able to select. Okay, so how I am able to decide that petal length will be my root node? Okay, it may be like sepal length, it may be a sepal width, it may be a petal width. Okay, so it may be any feature. So we need to decide like this root node with the help of some with the help of one with the help of applying a mathematics. So we need to follow we need to find out the something called an information gain. Okay, okay, so we need to find out the information gain. Okay, so just keep this term along with you. Okay, so that you guys if you are trying to, okay, so if you suppose if anytime if you need my help, if you want like a kind of a link or something, so yeah, you can reach out to me and you can ask me, and I will give you the like a link. If and even right now also. Okay, so just give me 1 minute if you want to study like the mathematics, if you want to read this thing in a better way. So you can follow this link. Okay, so every one of you try to open this link and and can try to understand. Okay, so 1 second, I just give you a link over here. So you can follow this link to understand like the things in much better way, maybe or not much better way, just to understand the mathematics. Okay, so what mathematics behind it, you need to understand that you need to find out the information gain. Okay, so there is one concept, information gain. So you need to find out the information gain of each feature. Okay, and the feature whose information gain is high, you need to select that like feature as a root node. Okay, so this is I think this is a very good blog where you are able to find each and everything. Okay, so you are able to find that how we can calculate the information gain and how you are able to calculate the trophy. So yes, you are able to see that they are able to calculate the information gain for Outlook. So this is example of like a play tennis. Okay, so this is example. So based on the weather condition, you need to predict whether you are able to play the tennis or not. Okay, so this is a data set for that, and you are able to see that Outlook is a root node. So why Outlook is a root node? Because the information gain of Outlook is high in comparison to any other feature. Okay, so information gain for Outlook is 0.224, information gain for temperature is 0.029, information gain for windy is 0.048, and information gain of humidity is 0.15. Okay, So if you make a comparison, so information gain for this output is high in comparison to any of three features. So yes, you can go for the like you can select Outlook as a root node. Okay. Now come again on to this. Okay. Fine. Now, yeah, decision tree, I think you are able to understand. So it's a so this is a like this is useful for the classification task, and you are able to. Is regression working formatted in the system? Regression working formatted in the system means I'm not able to understand your question. You want to see the implementation of any regression model or something? What? Okay. Now, okay. So this is I think, a decision tree which I think you already able to understand. The best thing is like its interpretability. Okay. So always remember that it's interpretable, and it's highly interpretable in comparison to any other language. Okay. So, and that is the reason why I choose this algorithm to do my practical stuff. Okay. Now, after selecting the best algorithm, okay, so based on your knowledge, when you select the best algorithm and you are able to prepare the data set, so now the last step is to go for the evaluation. Now you can check the performance of your model in two ways. So suppose if if your data belongs from like a regression task. Okay, so suppose if there is a regression task, so you need to find out a mean square error or root mean square error, as I already find out. And if suppose if it is a classification, so lower value is better. Okay, so definitely if your error is lower, then you can say the performance is good. Okay. And if in a case in case of a classification, you need to find out the accuracy score or maybe F1 score. So if accuracy score or F1 score is high, so you can say that my performance is good or better. Okay. Now this is again a kind of a evaluation. Okay, so in case of a classification, and why I'm going and why I'm showing you this graph, because we are going to do the practical implementation on a classification task. Okay, so in case of a classification, this is this confusion matrix is very helpful. Okay, this help you to understand how your model is performing. Okay, so I think you are able to see that this is your actual label. Okay, means actual output, okay, from the test data, and this is a predicted label. Okay, so means a predicted output means a predicted y, and this is the actual y. Now you need to make a comparison. Okay, so if actual label is also true and predicted label is also true, so that is called true positive. Okay, means your your model prediction is correct, because the actual label is also true and the predicted is also true. Okay, means the prediction is equal to the actual. Okay, so it means you are making a correct prediction, so that is equals to true positive. Now if your actual label is false, but your prediction is true, okay, so means you are making a wrong prediction. Okay, it is showing you the false, and you are predicting it as true, so it is a wrong result. Okay, so it is called false positive. Now if your result if your actual label is false and you are predicting sorry, if your actual label is true and you are predicting it as a false. Okay, so the actual label is true but you are predicting it as false, so again you are making you are making a mistake. So again this is called a false negative. Now the last case, your actual label is also showing a false and your predicted label is also false. Okay, so both, if if the diagonal is equal, so that is what we call you are making no mistake. Okay, so yes, this is called true negative. Okay, so in a diagonal you are making no mistake. Okay, so suppose if you need to find out an accuracy, so how you are able to find out an accuracy? You just add these two value. Okay, so suppose if I try to write a formula over here for an accuracy, so yeah, it's very easy to understand that what you need to do is if you need to calculate the accuracy score. So yeah, it's very simple. You only need to add true positive and a true negative, and you can divide this thing with a true positive plus false negative plus false positive and plus true negative. Okay, and this gives you an accuracy score, and definitely accuracy should be in some number, so you need to multiply this value with 100. So it will give you some kind of a percentage. So it may be a 80%, or maybe it may be a 90% or something. So if the percentage is better, is higher than the 75 or maybe 80, so you can say, okay, so my model performance is like good. Okay, it's fine. I can increase it, or maybe if I'm not trying to increase it also, then also it's good. Okay. So this is how you can evaluate the model. And now I think you are able to understand this pictorial representation. Okay, so this is what we are trying to understand from past 1.5 hour, that yeah, we are trying to fit our training data. Okay, and then we fit our training data into the learning algorithm. What maybe a possible algorithm you are using, maybe maybe a linear regression or maybe a decision tree. So you fit your training data, means your X train and Y train, into this learning algorithm. Then based so your learning algorithm creates a model, and your model is giving you a predicted value. Okay, so based on this unseen data, okay, so you have a this is your training phase, and this is your testing phase. Now this testing phase is having an unseen data. Now your model is making a prediction based on this unseen data, which is Y hat, and you already have a Y actual level. Now you need to make a comparison. Okay, so you need to make a comparison. You need to see how far your predicted data from the actual data. Okay, and this is how you need to find out an error, and this is how you need to find out an accuracy. Okay, so if it is not very far away, then you can say, okay, so my model performance is good. If there is a lot of difference between actual and predicted, so you can say, okay, so my model performance is not good enough. I need to implement, I need to modify it, I need to use some more steps and something, and I need to make it again and make it more accurate. So do we need to solve the regression offline, or can we solve in the session? Yeah, you can solve it on offline. Okay, offline. I think yes, you asked this question earlier also, that you are using an Anaconda and all. So any kind of a machine learning algorithm you can implement in Anaconda with the help of Jupyter Notebook. Okay, just when at a time of deployment, when you want to showcase something with the help of an web API, okay, or with the help of website, then at that time you need online connectivity, because if you share a website link with someone, so you need or how you can make that website link. Okay, so at a time of deployment you need an online connection or something related to internet or all. Otherwise you can build any kind of a model, regression, classification, or anything on your Jupyter Notebook itself. Okay, so it is perfectly it is fine. You can make it by using Anaconda and Jupyter Notebook. Okay. Fine. Now, this is what every machine learning engineer or every practitioner is need to understand. Okay, so this is till this point you need to understand, and these are all the stages which you need to follow to make a model, to build a machine learning model. Now, this last stage or this last step, like deployment, is not necessary for a machine learning engineer. Even so, at least for the fresher, it is not necessary. But suppose if the industry is growing and the industry is changing rapidly. Okay, so maybe in upcoming years they may ask to the fresher to make a deployment. And even if you are having maybe 1 or 2 years of experience, so definitely people ask this thing, that whether you you know how to deploy the model or not. Okay, so yeah, so you need to have some kind of maybe a knowledge of JavaScript and the Flask API. But suppose if you don't have that knowledge, or definitely at least in this class, many of you don't have maybe maybe a multiple knowledge. So knowledge from a multiple domains. So a very simple idea or very simple approach to deploy our model is a streamlit. Okay, so you can use this application, you can use this a streamlit application to deploy any of your machine learning model. Okay, and it doesn't require. Okay, so I think if you read this what you are able to see on your screen, so it doesn't need any kind of extra knowledge. Okay, so it doesn't require maybe any extra tool or any front end knowledge. Okay, you can deploy your model just so it able to turns your data scripts into a shareable web application. So you are able to convert your whatever the program you have written or whatever the model you have made, you can convert your model into an a web application just by using a Python script. Okay, so you don't need to apply any other knowledge, you don't need to have any other knowledge to deploy it. Okay, so using Streamlit, we can create a front end in Python script itself. Okay, so you don't need a knowledge of HTML and CSS. Okay, and without having a knowledge of HTML, CSS, also you are able to build this Python script. You are able to deploy your model, and you can make a beautiful UI. Okay, it may not a very beautiful or may not very attractive, but yes, at least kind of an UI which is able to represent your thing. Okay, and yeah, the very important thing, it is open source, and there is no charge is there. Okay, so this is the most important thing. So you can deploy your apps without paying anything. And the best thing about an Streamlit, everything you do is in the Python itself. So you need not to search for any other a language or any other a domain. And then yeah, all also starting from creating a model and then building a front end and then deployment, each and everything is available with the Python script itself. Okay, so you need not to worry about anything. Fine. So this is, I think, all about this session. And now I'm going to show you that how you are able to build end-to-end machine learning model. And I'm going to take a very interesting idea, a very interesting problem. I'm going to build a loan automation system. Okay, so we are going to build a system which is able to automating the loan prediction system. So if any person apply for a loan, so whether that person is eligible for taking a loan or not. Okay, so this is so this kind of a system we are going to build by using the knowledge which we received so far. Okay, so this is all about, guys. And now I'm going to show you that like a project. Okay, so I'm going to show you that practical implementation. Okay, so yes, again the same drive. So I think I add the book which you guys asked me yesterday. So I add a book also in this drive. So now if I share the a drive link with you, so you are able to get this real sales data along with if you try more hands-on, so you can try with a Netflix data also, although it's not important for now. Maybe if you are a beginner, so you can leave it. And I add this loan automation system. Okay, so this is a kind of a predictive model which I'm going to show you today. Okay, and along with this, I remember that I need to add one more thing. I think you guys asked for a Python book also. Okay, so I am going to add that also. And then and yeah, so this is our data set. So the data set is available in a CSV format, and this is my model. Okay, so let's see that how we are going to implement it. And I'm going to follow each and every step. Okay, so I'm going to follow even the exploratory data analysis also. Okay, so just I need to connect with my drive. So my file is not my drive is not mounted at. So I need to mount my drive. Someone asked Sir, will we upload the PPT presentation too with this? Okay, fine, no issue, guys. I will upload this PPT also in this. You want? Yeah, I will give you the drive link, and in that drive, I will upload the PPT also. Okay. Now this is my drive which I need to mount. Okay, so yeah, this is what I told you yesterday. So maybe if you're not able to understand, so you can understand it today. So what you need to do is, so as soon as you click on this mount button, you get this code itself. Okay, although you can like learn, you can memorize this code. Otherwise, it will you get this code automatically. What you need to do is you just need to run this code by using Shift Enter, and then you get a link. By clicking on this link, you get like your Google. Okay, so you get your account. So I think I'm using my personal account to create this. So I need to click on my personal account. I need to open my personal account, and then I receive a code here. Okay, so when I sign in here, so this is the code. What I need to do is I just need to copy this code, and I need to paste this code in this blank space. Okay, now I'm able to. Okay, so now my cell is running, and I think in few seconds I'm able to mount. Okay, so yes, I'm able to mount my drive. Now if you click on this link again, so you are able to see that the drive is here. Okay. Okay, so let's start with the first stage. So this is the problem statement, guys. So this company is approaching you, assuming that you are a data scientist. So the company is approaching you. So about the company, this is a dream housing finance company that deal in all kind of a home loans. Okay, they have a presence. They have presence across all urban, semi-urban, and rural area. Customer first apply for home loan. After that, company validates the customer eligibility for loan. Okay, so you need to make a model which through which you can calculate the validate the eligibility of a customer, whether they are applicable to for the loan they are applying or not. Okay, so the problem is company wants to automate the loan eligibility process in a real time. Okay, so they wants you to make a kind of a system which can process their loan eligibility process in a real time based on the customer details. Okay, so based on the inputs provided by the customers while filling online application form. These details are gender, marital status, education, then number of dependents, income, loan amount, credit history, and others. To automate this process, they have given a problem to identify the customers segments. Those are eligible for loan amounts, so they can specifically target these customers. Here they have provided a partial data set. Okay, so they give you a partial data set, and then they ask you to make a model. If they satisfy with you, so they hire you for to build a like model for them in a real time. So these are my basic libraries which I need to install: pandas, then numpy, then matplotlib, and then seaborn. Okay, now, and this is my data set. Okay, so I just copy the link of my data set from the drive itself, and then I paste that link over here. Okay, and for to see the first 5 rows of my data set, I'm using this function head. Okay, so head is also like a function of pandas itself. Okay, so I'm able to see the first 5 rows, and and these are all the columns we are available. Okay, so a gender, then married, whether the person is married or not, then dependents, then education, so the level of education of a person, then whether the person is self-employed or not, then the income, applicant income, then co-applicant income, then a loan amount, how much amount so the person the applicant asked for, then loan amount term, for how many days. Okay, so these are, I think, in terms of days or maybe a month. I need to check. Then credit history. So credit history is a most important factor in my opinion, because bank is able to give you the loan if you don't have any if you don't have any kind of a debt. Okay, so credit history is indicate that thing. Okay, so whether you are having any kind of a debt or not. Okay, so in your history, if you are having a debt, so definitely bank will not take a risk, or like any company will not take a risk to give you a loan. Okay, any company is able to give you the loan only in a case if you don't have any kind of a debt. Then the property area, so where your property are, and then loan status. Okay, so we all, so this is a kind of a supervised learning, and this is a kind of a classification problem, because we need to classify whether the person is belong into the criteria or category of yes, or whether the person is belong into the category of no. Fine. Now if I check the data set, so I'm having 614 rows, means 614 observations are there, and 13 columns are there. Okay, and this is the data set description. Okay, so loan ID is a unique loan ID. Then I think you are able to understand all these things. The only thing I think which include over here. Okay, so property area is urban, semi-urban, and rural. Then a loan approved, whether the loan is approved or not. So this is my target variable, and rest is 12 features is my input variable. Okay, now I think you are able to understand that and now we take some information from a data. So I just apply a info method. So info is again in the pandas itself. So I just apply a info method, and based so I'm getting this information. Okay, so this information method is giving you like a very basic and very important information about your data set, that how many data is present in a form of how many data is in the numerical format. Okay, because we need to convert a categorical data into a numerical one. So we first need to know, okay, how many data is present already in a numerical format, and how many data is present in a categorical format. Okay, so I think you are able to see that 8 out of this 13 observation, out of these 13 columns, 8 columns are present in a categorical format. Object means categorical data. Okay, so you are able to realize it, like this is a categorical format, this is again a categorical data, this is again a categorical, and then a categorical. So your 8 columns out of 13, 8 columns are categorical. Okay, an object. Only 5 columns are numerical. Okay, and then you have some null values also, because out of 614 it is written over here non-null means there is no null values. But if you are having 601 non-null values, it means you have 13 null values. Similarly, in case of 614 non-null values, it means you have 3 null values. So you have very little amount of null values, but you have like a null values. Okay, so this information also you are able to gather from this place. Okay, so I think someone asked you in like very early that how you are able to check whether there is a null value or not. Okay, so this is also a way. Okay, so there is another way also, but this is also a way through which you are able to check whether okay, so you are able to check. Okay, so now you are able to you can say, okay, so in a gender column there is like 13 null values. In a married column there is 3 null values. Okay, so you are able to calculate the null values. Fine. Now I just drop the irrelevant column. So loan ID is totally irrelevant. It is not going to give me any kind of it is not important at all. So I just drop the loan ID column. Okay, now I have 12 columns. Out of that 12 columns, 11 are features and 1 is target variable. Okay, now I just come on to the second stage. Okay, so I collect the data, I gather the I understand the problem, I collect the data. Even I just understand some of the basic information inside the data. Now I need to explore the data to get more information, to get more insights from the data. Okay, so the very first thing which I need to check, how many okay, so out of this 614, how many loans are approved and how many loans are rejected. Okay, so so I need to check whether my class is balanced or imbalanced. Okay, so it may possible that a 90% data is fall into the category of yes, and this 10% data is fall into the category of no. So I must say that my data set is quite imbalanced. Okay, but if there is a 70-30 ratio, or maybe a 60-40 ratio, or 50-50 ratio. So I can say, okay, so my data set is quite balanced. It is not imbalanced. Okay, so first I need to check that. Okay, so how the distribution is going on, how the class distribution is going on. So I just use my knowledge in Seaborn. Okay, so I just use a Seaborn library, and with the help of that Seaborn, I make this pie chart. Okay, and this pie chart give me a very clear intuition that 68.7% data, like a 68.7% loans are approved, and just 31.3% loans are rejected. Okay, it means that it is like somewhat 70-30 ratio. So it is a quite balanced data set. You can't call it as an imbalanced data set, and that is what I written over here. Okay, so this is I have written in a markdown that from above pie chart, and this is the important thing, you need to write your observation everywhere, then only client is able to understand that yes, this is the kind of observation I am getting. So from above pie chart, we can see that around 69% of the loan has been approved, while 31% loan application was not approved, which means about 2/3 of the applicants have been granted loan. Okay, yeah, and this is true at all. Okay, and so this is the kind of information I'm getting from this pie chart. Okay, now I just apply some more EDA, and I try to perform some univariate analysis. So I think yesterday itself I told you that what is the meaning of univariate analysis. Okay, so you just try to try to make your analysis on a single variable, one variable. Okay, so that is called univariate analysis. So you are trying to check, okay, so how many number of okay, so whether the male is higher or maybe a female is high. So you are able to see that the male is much more higher in comparison to female. Then there is more married people in comparison to non-married people. Then in case of education, there are more graduated people in comparison to non-graduated. Okay, and there are more people belongs to from a semi-urban area. Okay, and I just tried this observation over here. Okay, so there are more men than women, approx 3x. Okay, so yeah, this is true. Okay, so like this graph is like 3 times more than this female. Okay, now bivariate analysis. So I think someone asked me yesterday to try to check the sale of a particular month of any product. Okay, so that is what we call as a bivariate analysis. So, and this is what we are trying to check over here. Okay, so I'm trying to check what is the impact of a gender on the loan status, what is the impact of married on the loan status, what is the impact of dependents on the loan status. Okay, so I'm trying to check the impact of each feature onto the loan status. Okay, so and that is why it is called a bivariate analysis. Okay, so I just try to take two what you can call it as two column into a consideration. Okay, so and this is now my observation. We can observe that male applicants had more chances of getting loan, and I think this is you are able to understand why this observation is there, because the male candidates are 3 times more than the female candidates. Okay, so yeah, this observation is very obvious. Can we analyze the reason for non-approval of 30%? Yeah, that is what we are trying to see in this graph. Okay, so maybe you can try to analyze that 30%, why that 30% is not approved. So you can try to analyze in this place. Okay, maybe you can try to make a more specifically, you can make a pie chart. You can make a more graph, or I think you are able to analyze from this place only, like a 2/3 population in the data set is married, and married applicants are more likely to granted a loan. Okay, so the reason for not granted a loan is maybe your because you are a single, so it might be also a chance. Okay, then in case of education, so 5/6 population is graduate, and graduated people have more proportion of loan approval. So if you are not graduated, so it might be a possibility that your loan is not going to approved. Okay, so and I think this is the most important feature, I think, which I told you earlier. That is what my hypothesis is. That applicant with credit history are far more likely to be expected. Okay, so means if you don't have any kind of a debt in a past, okay, so your loan must be approved. Okay, so that 30% people must have some kind of a debt in past. Okay, and that's why, and that maybe that might be a possible reason why their loans are not approved. Okay, now we are trying to see the relation between like a numerical features. Okay, so my numerical features are loan amount term and loan amount and like co-applicant income and applicant income. So I think you are able to realize that loan amount is directly related to it should all directly relate to the your income. Okay, so if your income is very high, so you can ask for the like a maximum number of more amount of a loan. But if your income is not very high, so it may possible that you can ask for a bigger amount of a loan, but it is like the possibility is very low that a possibility of approval is very low. Okay, so there is a direct relation between you can say that there should be a positive relation, or there should be a direct relation between a loan amount and the applicant income. And this is what you are able to see, the applicant income. And if I see the loan amount, so this is a kind of this is a kind of a relation. Okay, 0.57. Okay, so 0.57 is a positive relation, and 0.57 is like a good percentage. Okay, so the 57% connectivity. Okay, so in between applicant income and a loan amount, there is like 0.57 relation. Okay, and in most also co-applicant income, so with the help of with co-applicant income, it is making a positive relation, not a very good positive relation, but yeah, it is making a positive relation. If you check with the loan amount term, so it is making a very it is making a no relation at all. And you need not to check the credit history. Okay, because credit history is a discrete value, it's not a like continuous value. Okay, so you can't check a credit history. Okay. Now fine, it's time to apply some feature engineering. Okay, so you can check the null values by using this is null function also. So you can apply is null dot sum, and you are able to so is null means whether there is null value or not, and if there is null value, just try to sum up. Okay, so gender is having 13 null values, married is having 3 null values, then dependent is having 15 null values. Okay, so these are all the null values you are having, and you are able to see that you don't have like 70% of missing values at any place, because you have just a very few number of missing values. Now what you can do is you need to fill these missing values with a mean, median, or mode, as I told you. Okay, so a credit history you always try to fill the categorical data with a mode, and you always try to fill the numerical data with a mean or median. Okay, and why? Because mode is what? Mode is the most frequent value occurring in a data set. Okay, so mode is a most frequent value occurring in a data set. Okay, so in case of a categorical variable, you can't find out a mean or a median. Okay, so in case of a gender, male or female, you can't find out a mean or a median. You can find out what may be the mode. Okay, so whether a male is like a mode, or maybe a female may be a mode. Okay, so you can fill the null values in case of a categorical data with a mode. Okay, so that is what we are trying to do. So gender is a categorical column, married is a categorical column, dependent is a categorical column, self-employed is a categorical column, and credit history is a categorical column. So we try to fill the like null values inside these categorical column with a mode, and we try to fill the null values in this numerical column with a mean. Okay, so this is what we call the imputation. Okay, so we just try to fill the null values. We are not dropping the like column, because there is very few null values are there, and if we try to drop this column, so definitely we are going to lose like lot of information, and we are not able to build the model. Okay, so we are not going to drop it. We just impute these null values with the help of mode and a mean. Then again, if I try to find out whether like something is left or not, so no, I'm able to fill all the null values. So it's good. Now, the second job which I need to do is we need to handle the categorical variable. So I tried to handle the categorical variable just by using like replace function. And here I'm trying to handle the categorical variable with a level encoding. Okay, because I don't want to increase the dimension. Unnecessarily, I don't want to increase the dimension. So I just use a level encoding technique, and now you are able to see that gender becomes 10, merit become 10. So each and every categorical data is converted into a numerical values. Okay, so finally we have all the feature with the numerical value. Okay, so you don't find any categorical data now in this data set. Okay, so my job is done, the feature engineering job is done, and definitely I didn't apply much like feature engineering, because my idea is to show you only the like kind of a system. Okay, yeah, definitely if you like make some practice and if you do some kind of a step by yourself, so I will be more happy. So you can like do some kind of a stuff. You can do like one hot encoding maybe in place of level encoding. And yeah, so that is based on like like whatever the knowledge you can collect from maybe some any other place, or maybe by just enhancing this knowledge, this 2 days workshop knowledge. Okay, but yeah, we convert all the categorical data into a numerical one, and then we split the data as I told you. Okay, so now this is called a data preparation. Okay, so I just split a feature and a target. Okay, so inside a X I include all the features. Okay, so I didn't include all the feature, I just include some of the feature. Okay, so the feature which I think, okay, so these are the important one. Okay, so gender, married, applicant, income, loan amount, and credit history. So I just take 5 features in my X, and I take a loan status in my Y. Later stage you can change it also. You can add maybe a more feature. Okay, so it's up to you. Then I split the data into training and testing set. Okay, so I just take 80% of the data for the training purpose and 20% of the data for the testing purpose. Okay, so this test size is 0.2. So 0.2 means 20%. Okay, so means 80% of the data I use for the training purpose. So this is now the shape of my train and test data. And now I'm going to use a decision tree classifier to build a model, and I'm using a accuracy score, F1 score, and confusion matrix to evaluate my model. So so this is my decision tree classifier, and I'm using a def test 3. So I just want like def test 3. So that is fine. Now I just so here I am able to get the predicted Y, and my actual Y is already in my Y test. So and now I'm making a comparison. Okay, so you are able to see then inside an accuracy score I put 2 values. One is Y pred and another one is a Y test. Okay, so this is what I'm getting from my model. Okay, and this is what this is what actually present inside a data set. Okay, so now if I make a prediction, if I try to find out an accuracy, so accuracy is 78.8%, F1 score is 85.8%. so it means that the performance of model is good, and I can try to make a confusion matrix also. Okay, so 18 plus 79, so these are the correct prediction, and 26 predictions are wrong. Okay, so out of 123, 79 plus 18, if you make a calculation, so I think 98. So 98 97, so 97 predictions are correct out of 143. Yeah, out of 123, and 26 predictions are wrong. Okay, now I can make you. Okay, so this is how my model is going on. So as I told you that credit history is the most important feature. So this is like information gain of credit history is high, so that is why it becomes a root node. So it first check the credit history, whether the person is having a credit history or not. So if it is true, then it is checking for the loan amount and it approves the loan if the if there is no credit history. If it is false, then it check for the married. Okay, so married is the second important feature. Okay, so this is quite interesting that people must so person must be a married one. I think this company is more fruitful for the married couple. And then it check for the loan amount and the applicant income. Now here I just preserve my model in a form of a pkl. Okay, so pkl is like pickle file. Okay, so we make a pickle file to so pickle is a format in which I need to like we can save our model. Okay, so we just save our model in the pickle format. Then this is a Streamlit app which you need to install, and along with the Streamlit app, this is called a PyNgrok. Okay, so PyNgrok is a library which actually build a front end for you. Okay, so this is a library which actually build a front end for you. And then this is a token which you need to take for the to run this PyNgrok. Okay, so the token is easily available for you. What you need to do is you only need to go in PyNgrok. Uh, okay, so I think PyNgrok. Sorry, ngrok only. You need to write ngrok, and then this is a website. Okay, ngrok.com. Okay, so this is a website. So from here you can just sign up. I already have an account, so I can log in. You can you just need to sign up, and after sign up you can create your account, and after creating an account you just need to log in into that account, and and this is your dashboard. Okay, so from dashboard you only need to find you need to copy this thing. Okay, so mine is different, yours is different. Okay, so this is the token. So not this thing, not this. You only need to copy this much auto token and all. Okay, and you just need to put this token over here. Okay, I think the complete setup, I think we need to copy. Yeah, sorry. So in place of this dollar, you only need to put the exclamation mark, and you need to copy. Okay, so just like I copied the thing, you just need to copy your token after signing in this account ngrok. Okay, so just run this token, and now this is your like web app. Okay, so this code is like available for you, and all the things are already done. You only need to do the modification like based on your data. Okay, based on your model. Okay, so what model you want to open? So this is your model which is already saved in the pickle format. So I think you know the read and write mode. So you you use the write mode at the time of saving the model. Now when you need to read when you need to again use the model, so you need to apply a read mode. Okay, rb. Now these are all the features which you are passing to get your prediction: gender, married, applicant income, loan amount, and credit history. So you just make in a form of if else, and then loan amount, you divide just loan amount by 1,000. If you don't make it, then also it's fine. It's not like a big thing. And then you make a prediction. So based on this feature you make a prediction. So if it indicates a 0, so it means you are going to reject the a loan loan application, and if it is like 1, so you are going to approve it. And this is your main function. So these things are already available. So I think this much of knowledge, every one of you having this much of knowledge. So background color is yellow. If you want to change it, you can make it green, red, or based on your choice. Padding is 13 pixels. So padding is just a space. So you can if you want, you can create a more space. Then like a heading color, it's black. You can change if you want. Okay, and this is the name: automated loan prediction app. Okay, so if you want, you can change the name also. And fine, so these are all the box which is available. So this all code comes from the PyNgrok itself. Okay, so you need not to worry about this. Only you need to you can make your own modification. So suppose for loan amount, you need to put the loan amount, a number. But in case of a married, you need to select whether it is married or unmarried. Okay, so you need to make a box. Okay, so only this modification you can do. Okay, so suppose the next feature, suppose if you want to add more feature, so if your feature is a categorical, so you need to make a select box. If your feature is a numerical, maybe if you want to check a co-applicant income also, so you need to use a number input function. Okay, and then fine, this is a button. You need to click on the predict button, and then it is going to show you the result. Okay, so whether your loan is approved or rejected. Okay, so fine, I just read this line of code, and then finally I'm going to run this, and this is going to give me the URL. Okay, so now if I click on this URL, and so this is my web app. Okay, so this is my web app where I can put the information of a customer, and I can predict the result. Okay, so it will okay, fine. So the gender is male, marital status and unmarried is fine. Then applicant monthly income, so maybe I can put maybe a 40,000 over here. I can ask for maybe a loan of 6 lakh. I think this much loan is easily available for me, and I don't have any unclear debt. Now just make a prediction. Yeah, my loan is approved. Okay, so yes, and you can use this app. You can use this like the whole learning which you learn in a workshop. You can you can post this thing on a LinkedIn or maybe on a GitHub, and definitely you can showcase of these things. Okay, it will definitely boost up your resume. Okay, so yeah, this is all the things which you need to build. And after building a model, after creating a URL, you need to kill this site. Okay, because if you didn't kill this site, and next time if you try with some other maybe a model, so it will create a problem for you. Okay, so just always just create this habit. Always try to kill your URL. Okay, so I'm going to kill my URL because my work is done. Okay, so guys, this is all from my side. Now, if you have any query or any question, or if you want any other help or consultancy for me, so yes, you can ask. Okay, can you suggest a library for adding custom voice to computer using Python? Bro, just go on to the Google and just because custom voice, yeah, but the library is definitely available, but I didn't remember instantly. Okay, yeah, you can search it. Like you can just put the same question on a Google, and Google will answer you. Sure. When can we get our government approved ESATO? I am not the right man for this question. Maybe the team can answer you. I think it will be very soon. They didn't take much time to give you the certificate. Okay, any other question?
Sir, have you shared this link yesterday, sir? Like the material link and the drive link with data, sir?
Yeah, that's why I add the book in that drive link, because I'm going to share that drive link only. So what else information if you want, so you can ask me. I will add those things also in your drive. This is a
Sure,
basic what is the okay.
Sir, I think yesterday we did not get the link, sir, or I might have.
No, maybe they are waiting for like today's session. No? So
Sure.
like complete thing in a one link is good. Okay,
Sure, sir. Sir, actually, you have done all these things manually, right, sir? So we have some automated products from Data Robot and Amazon SageMaker. So with these things, like with these kind of products, we can do all these things very easily, right, sir? But the ultimate thing is that we should be doing it in this way. Like if we have programming knowledge, it would be very useful to understand those concepts, right, sir? Okay, sir.
This is the basic. What is the next in Python? This is the basic in machine learning, and not a very basic, because we implemented a model also. So you can't say this is only a basic. But yeah, this is a basic in a machine learning, not in a Python. So in terms of I didn't teach you the Python. Okay, so I just because maybe the prerequisite is you need to know the Python little bit, at least the fundamental, at least the data types. Okay, so I didn't teach you the Python, I teach you the machine learning. So this is the basic of machine learning. In terms of language, in terms of a Python, so for to understand this thing, you know the basics of Python. Okay, so you at least know the data types, you at least know the functions, or you know the you must try to analyze the yeah, at least the data types and functions you need to learn. Okay, and then you are able to understand, you are able to program these things. Okay, although you are able to understand, but you are able to program these things in by your own, if you are comfortable with the Python. Okay, so if you are comfortable with the data types and functions in Python, so you are able to program it in much easier way. Okay, so in case of joint application of for loan, how is the data processed? In case of joint application means
Sir, I think two members applying for the loan, like father and son, they apply, right?
So we are checking for multiple members. Yeah, at the same time, we can't check for the multiple members. You need to have two systems for that. So this is a URL. So anyone can multiple people can sit with the same URL and then check whether they can approve the loan or not. Okay. Okay, guys. So anyone else having? Yeah. Thank you so much for your appreciation. Anyone else
Thank you,
having
sir. It was a
any
very
query?
informative session, sir.
Thank you, sir. It was very nice having getting knowledge from your side. It's really interesting. We will get to know the details more into that. It's a basic thing only. Thank you.
Yeah.
Thanks for your good knowledge and training, I can say.
Thank you so much. Thanks.
Yeah.
Thanks to you.
So
Thank you, sir.
thank you very much, sir. Anand here. Thank you
Yeah.
very much. It was very knowledgeable and